All right, any questions on the problems up through, I think, number 9 that we had?
You didn't tell us the answers when we changed it in.
I know, that's sad.
So can you tell us the answers?
I can tell you the answers. We can go over them if you'd like.
Okay.
I know, it's sad when you don't get immediate response. It's almost like a test. Oh my. What would you have done 20 years ago? Now I'm sounding like Faith. Okay, question number. All right, let's go over this. So this one, 73% got right. If we do E1 on this is problem 7. So if we do an E1 on this, what's the major product of the reaction? Oh no, I don't have the wheel to spin. Which one?
Both A and B.
Both A and B are the major products? We agree? Do we know where that's coming from? No? When we go to an E1, mechanism, the stereochemistry does not matter in that case. And so our steps are still the same. What was the first step in solving one of these problems? Determine the alpha and the beta alpha carbon, and then all of the beta carbons. And there's three beta carbons. Then determine whether the hydrogens can be removed if this was E2, right? And so this hydrogen here would have to be bold. It's CH3. That hydrogen could be removed, and the hydrogen on the bottom beta carbon cannot be removed in E2. But this is an E1 mechanism. So how does that change the hydrogens?
So on the that's a CH3, so are you just like drawing
All I'm doing is I'm just making it a CH2 with the H so that I can explicitly show the beta hydrogen. That's all I'm doing. So when I go to E1, what happens to those beta hydrogens? Stereochemistry doesn't matter, right? Because once the bromine leaves and we form a carbocation, then once you form that carbocation, it's going to have a empty lobe above and below. So all the hydrogen has to do is just become parallel to one of those lobes. So there's no restriction on the hydrogen having to be trans. The cis or the trans hydrogen can be lost in E1. Okay. So that means that all 3 hydrogens can now be removed. And so then the question becomes, in E1, what's the major product of an E1 reaction? The most substituted, most stable product. So in this case, the 2 products that are most stable are going to be having the double bond to the top carbon to form product A, and then the double bond to be the double bond from the alpha to the bottom beta carbon to produce product B. because those are the two most substituted alkenes. So we have to keep that in mind. When I go to E1, there's no more stereochemistry. Stereochemistry doesn't matter. If it's got a beta hydrogen, it can be lost. What product am I going to form? The most stable product. And in this case, there's two most stable products. Okay. So that would make the major product A and B, which in this case would be product would be answer D.
If it was E2, would it be C then?
If it was E2, it would only be C.
Okay.
Because that's the only hydrogen that can be removed by a base that can become antiperiplanar. I think if I show the correct answer, then it will translate over to you being able to see the correct answer after class. I don't know. As we go through here, we'll see whether or not that's the case. Otherwise, I'll find a way for you to see the correct answer, except the one that's wrong. There is a correct answer that's wrong. And I have to fix that, but if I wanted to fix it yesterday, it would erase everybody's scores. So, okay, does that make sense for that one? So now some more of my problems. This one was 77% correct. So for this reaction, we're going to use tertiary butoxide. So if I use tertiary butoxide on this alkyl halide, which product was the major product?
No reaction.
No reaction. B. B, no reaction.
B and C.
What?
I said
D. You'll say D? Okay. Let's see what people said. The most popular answer was B. So for this one, and I did say something about 5-membered rings versus 6-membered rings, and I think what I said was I can change a 6-membered ring to a 5-membered ring, and I basically get the same problem, except it's perceived as a brand new problem. So that means I have a variety of problems that I can ask. And as you've seen, I can ask 4 or 5 different questions out of every single problem. So you got to go to the basics. So the basics in this case would be I'm using what? Tertiary butoxide on this? All right, step 1. Alpha, beta. Alpha, beta, beta. Let's look at the beta hydrogens. Okay, there's 3 beta hydrogens, 2 on the top carbon, 1 on the top carbon, 2 on the bottom. All right. So let's call this one A, we'll call this one B1, and we'll call this one B2. So which of those hydrogens can be deprotonated E2 by the tertiary butoxide?
B2.
B2? Any others? How about hydrogens C1 and C2? Can HA be deprotonated? Yes or no? No? HB1, HB2, HC1, HC2. Why not? Exactly. They're not beta hydrogens. They're what? Whatever the next Greek letter is. It is. In certain organizations you'd have to be in, you'd have to memorize the Greek alphabet. So it's gamma, if that's a gamma. So only the beta hydrogens we're going to take a look at. All right, so B2 is the only one that can be removed, therefore product B is the only product. Now C, no C. There's no C product because there's no double bond on the bottom because C1 and C2 are not beta hydrogens. Bobby?
Why is B1 not a beta hydrogen?
It is a beta hydrogen, but it's not trans to the leaving group.
So it can't be removed?
Nope. Only the beta hydrogens that are only the beta hydrogens that are trans to the leaving group. B1 is cis. Jacob?
Oh, okay. I didn't realize that A, B, and C, like they were labeled that.
I think that's...
I didn't realize that was like one of the options.
Yeah, A, B, and C were the products.
Yeah.
So the only way you get product C is if you were... Well, you can't actually get product C.
Well, I thought the only options were B. I didn't realize that those were like...
Oh, yeah. No, you got A, B, C, and then you've got these combinations, the way I write them. Because we can't do multiple... The only way I can do multiple ones is if you typed in the exact letters.
It has to be it has to be trans.
It has to be trans. Beta hydrogen has to be trans to the leaving group. Cis will not react in E2. It will in E1, but not in E2. Okay? All right, so that's number 2, pretty good. Now for the NH2, we're down to 54% correct. And in this case, I'm using NH2 minus. Now, just going back to the original molecule here, what's the only hydrogen that can be removed? HB2. It doesn't matter what the base is, as long as it's E2, that's the only base that can be removed. So the major product of this reaction, using either terse butoxide or NH2 minus is product B. That's the only product that can be formed in an E2 mechanism. So again, it's that sequence of rules. It's a sequence of steps. You got to determine what hydrogens can be removed by E2, because that's your only choices. Then you go to the base and say, is it removing the least sterically hindered or is it forming the most stable product? But you have to have a choice. And so in this case, there's no choice. It's going to be B for either base. Okay. If I do that, do you see the correct answer? Somebody who's looking. Bless you. All right. Then I'll have to figure out how to do that. Okay, so is everybody okay so far? No one got the next one right. E1 without rearrangement. Could be that the answer key is wrong. What was our most popular answer? A. Okay, without rearrangement, the most popular answer is A. Again, going back to that molecule, now I've changed it to E1. And so which one of these hydrogens can be lost? All of them, any of them. And so now the question is which product is the most stable? It's to lose HA and form the double bond there, so that's product A. This is without rearrangement. The next question is with rearrangement.
Rearrangement. Is that actually?
Yeah.
Oh, never mind.
That's the next one. So without rearrangement, you're putting the carbocation here, and you're losing HA, because stereochemistry doesn't matter. The next question is, what would be the reaction? What would be the product with rearrangement? So now with rearrangement, the first step in the mechanism is going to be to lose the bromine and form that carbocation. And so now we're going to do a rearrangement. So my question would be, which hydrogen is going to shift? H. I hear just one A. Should I hear more A's? What's our criteria for doing a rearrangement? Have to make the new carbocation more stable. I have to form a more stable carbocation. So that means if HA shifts over, we have what kind of carbocation? Tertiary. And so now when you do a shift, I got a new alpha carbon and new beta carbons. Right? Because after I do the shift, my alpha carbon has shifted. So now I have 3 potential beta carbons that can lose hydrogens. 1, 2, and 3, except 2 and 3 give So here's the products. The product would be 1, 2, and 3. Why am I calling out products 2 and 3? Because they're the same product. Products 2 and 3, bless you, are both 1-methylcyclopentene. So they're the same product. So really it's a choice between 1 and 2. Again, I'm doing an E1 mechanism. As soon as I form the carbocation, it becomes E1. E1s always give the products that are most. So that is product 2, which was product 3, which is product A. So actually, in this case, I get the same major product whether I do a rearrangement or not. Hence the problem of trying to determine whether or not rearrangements really occur. Although there's ways around that. So for both of those, it's a question of carbocation. Then if I need to rearrange, I need to reset my alpha and beta carbons. Right, which everybody's been doing fairly well. This problem, 33% got right. And I know the answer key is correct for that. Okay. For this problem, what is or are the major products? Do we need help? So it was the same molecule, wasn't it? And the first one was reacting with hydroxide, right? Okay. I'm stuck. I don't know what to do. Help me. Josh?
This, you have to determine if it's S1 or E1. SN1 or E1.
Or SN2. Or E2. All right, so, and this is chapter 11, right? Because it's going to bring all four together. So let's go one by one. Is this reaction E2? No, why not?
The only bases we use in E2 are the NH2- and the tertiary butoxide.
Yes. So if it doesn't have NH2- or tertiary butoxide, it ain't E2. So we can eliminate that one. On the other hand, if it has tertiary butoxide or NH2-, it definitely is E2. So it's not E2. So now we're down to E1, except the problem with E1 is it always goes with SN1. So is this SN1 and E1, or is it SN2?
You can look at the nucleophile. That is nucleophile.
This is a strong nucleophile. That's a factual statement. It's okay. We needed to know that information. What kind of halide? Primary, secondary, tertiary. Secondary. So I got a secondary halide reacting with a strong nucleophile. What mechanism is that? Exactly. We need to go back and we need to rememorize the chart. Remember the chart that says primary plus strong is SN2, primary plus weak nucleophile is no reaction. We modified that chart by saying everywhere SN1 was, it's now SN1 plus E1. Okay, nobody ever said you could forget about the chart after the last exam. You'd really never forget about the chart. We're just going to be modifying it along the way. So that gives us a mechanism that is SN2. Okay, so I need that information in order to be able to write the major product of the reaction. Substitution means what? I'm going to substitute what for what? I'm going to substitute the bromine with the OH. Great.
Would there be an inversion because it's SN2?
SN2 goes by inversion of configuration. So what wedge goes on the OH? Bold, dashed, or both? I hear dashed. Do we support that? And here's what happens. The OH minus comes, it has to come from the opposite side of the bromine, so it has to come from underneath and kick off the bromine. And when it does that, that puts the OH on the dashed wedge, having come from underneath the ring. Also, whatever the stereochemistry here was, it's got to be opposite. So what I've done is I've switched the H and the OH, that's one switch, basically changes the configuration. So that's the major product of that reaction. So it's inversion of configuration because it's SN2. So I need to know the mechanism I need to know the mechanism of all these reactions. It's just sometimes I've told you whether it's E1 or E2. So this is SN2. And if none of this if something doesn't make sense, you got to yell. It's 1 o'clock in the afternoon. Everybody should be somewhat comatose, or not comatose, I guess. 8 o'clock in the morning's a little rough. People just stare at me. Not to say that doesn't happen here. Somebody on Friday at a workshop talked about zombie students. I hope we never have that. Because there's nothing protecting me from, there's no moat or anything here. Next problem is with water. Okay, so if I change the solvent from OH minus to water, what happens? Go ahead.
It's a weak nucleophile.
Okay. Weak nucleophile, so what? SN1
And E1.
and E1. Yep. So it's SN1 and E1. So if I go back to my products then, which I will in a moment, we need to know, okay, what happens with the, well, let's just draw out the structure of the SN1. When water reacts, what's going to be left over at the end? What am I substituting bromine with in the end? An OH. Okay, so there's my OH. What wedge? Bold? Both. Bold and dashed, right? Which of those two is major? It's what? It's racemic. So that means it's 50-50. So both of those are the major SN1 products, the racemic mixture. And we'll just leave it at that. E1, what's the major E1 product? Without rearrangement. Where's the double bond going to go? Here's my alpha carbon, so it's got to go between the alpha carbon and either the top beta carbon or the bottom beta carbon. Top. So all three of those products are the major product. So that means if we go back, it's going to be A and B and D, which is F. Choice F. So let me show the correct answer. Wait.
You're on 5.
Oh, that's right, I'm on 5. There, F. We had lots of answers for that. Now, just so you know, on the next exam, unless I'm super stressed for time, I'm probably not going to format the questions like this. I'm going to ask you to identify the major product and products of the reaction, which kind of cuts both ways, right? Because you could get partial credit if you get like 1 out of 3 or 2 out of 3, where you get no credit if it's multiple choice, which is the conundrum between multiple choice and writing out the problems, which is more rigorous. Somebody needs to do some educational research on that. Maybe next semester I'll do that. I've already done a little bit. I can give you a quiz with the written out answer, and then you flip it over and you have a multiple choice answer you can choose from. And then I track student by student who got the question right and wrong and how much of a difference it makes in their overall score. And it depends. But I would suggest that maybe the problem-solving strategy here would be to write out the product, the product structure, and then choose the multiple choice answer. That's just me, right? But to me, that would make the most sense in any kind of a multiple choice test, unless you're completely lost or you can eliminate things. But you're probably gonna have to write out the product, so you still have half a problem set left, so maybe you could try that. Okay, everybody still kind of with me? Okay, 70% got this one question right. This is with tertiary butoxide. So again, it's pretty tedious. Find the alpha carbon, find the beta carbons. And in this case, got an alpha carbon, got 1 beta carbon, 2 beta carbons, 3 beta carbons. And I forget what it probably goes A and B and C. Yep. So if I'm going to react this with tertiary butoxide, which hydrogen am I removing? Which one? The least sterically hindered, which is B. So this is primary, this is tertiary, and this is secondary. So if we're looking at steric hindrance, that's going to be our first criteria. What kind of hydrogen is it? What kind of hydrogen it is the carbon that it's attached to. So primary hydrogens are attached to primary carbons. So we first go primary, secondary, tertiary. Then if we're kind of tied, we can look at the surroundings, like we did on Monday, when we had a methyl group versus an ethyl group, 2 tertiary hydrogens. Well, the methyl group's going to be a little bit easier to get to because it's smaller, the one that's next to a methyl group. So in this case, we're going to have the double bond attached to the CH. It's going to be a double bond to CH2, which is product B, and product B should be the correct answer, which it is. And then we can go through the others. NH2 minus. Oh, we're up to 85%. Good. So for this one, if we used NH2 minus, we're going to form the most substituted product, which is A. Okay. And in this case, A, B, and C are all legitimate products because they've all had beta hydrogens removed. I'm not limited to giving you legitimate products, right? I could remove a gamma or a delta hydrogen, and so you've got to make sure that, because if you just look and say, oh, it's the most stable product, and that didn't come from beta hydrogen, deprotonation, then that's not the correct answer. So you've got to go back to basics for these problems.
So C is like present in all the products, but it's just a really small amount. Would that be
Right. It could be present, but it's not going to be the major product. I mean, I don't know how the percentages would go. We'd have to actually do that reaction. And if we did that reaction, then we could find the products by like GC or something. But we would predict A would be the major product with NH2 minus. We would also predict that A would be the major product with what reaction? E1, which is the next one.
Would it also be it with SN1 if we had to do it or no?
Good question. So this would be the major product if this was E1. Because E1 and NH2 will give the same products most of the time. Not all the time, but most of the time. And why I'm saying most of the time is, when wouldn't E1 and NH2 minus give the same product?
If there was a rearrangement that made it more stable.
NH2 minus isn't going to rearrange.
The
The E1 would rearrange, but the NH2. So I suppose that's true. But when else would it not? The requirement for E2 is what kind of hydrogen? Anti-periplanar, so it's possible you may not have a hydrogen that's anti-periplanar, but once you go to E1, that hydrogen could be lost. So they sometimes do, but it's not a guarantee. Okay. We're getting close here to the end, aren't we? Oh, the last one. 79%. And this one was E1, because that was the major product. I don't have the remainder of the problem set into Top Hat. When I decided to use Top Hat in the spring and they were going through it with me, I said, oh, well, then I can take all my electronic homework problems, or not my electronic homework problems, but all my handwritten ones, and I can convert them into being electronically graded. And it took me 3/4 of a semester to actually do that. So you may see more of this as we go along, because I can do that. Now I got to figure out how to actually let you see the correct answers. But on Canvas, this problem set is in Monday's folder, and also with it is a letter answer key telling you what the correct answer is by letter, and then there's also a narrated answer key so that you can go through and for the remainder of the problems you can see whether you got it right. If not, go back and redo it. And then if you're totally, I don't know what to do, then you could go ahead and look at the narrated answer key. And with the narrated answer key, you can just look problem by problem. You don't have to, listen to the whole thing. You can just move the little red thing around to the answer you want to see. Right. But I do let's go back to that question, the question about this. Can that undergo SN1? I'm curious. Matter of fact, I'm so curious. So, can this undergo SN1? Good, nobody's answered yet because I was anticipating answers flowing in when I haven't said that A would be yes and B it's in the wrong class. So were people going to answer? Oh no, where'd it go? All right. This way you can get your day's presentation points or participation points. And these are being graded by participation point, not on correctness. All the problems that we did. Josh?
Would you be able to put bold and dashed wedges on the carbons?
You want me to put bold and dashed wedges on this molecule?
Because that would be necessary.
Are you sure? All right, I'll give you bold and dashed wedges. Hold on, here we go. Okay, so A, yes. B, no. Do you need C? No. Here, I'll do it this way. A bold dash on the bromine, and we'll do a dashed wedge to the ethyl group. So will that undergo will it undergo SN1? Answer that question. Then I'm going to come back. What I did what? Oh, you can do that. Didn't know that. I know if I close a question out before I get the results, I can't see it. Learned that this morning. There's just too much technology in my head right now. Is anybody doing the entrepreneur high school thing tomorrow? Because they're in a linked class. Nobody in here is? Okay, then never mind.
Why, Lord? What about it?
Well, if somebody was doing it, I'm supposed to go from lab to give a quick 20-minute TED-like talk, except it won't be as interesting as a TED talk. And I need to know, and if somebody was there, they could text me and tell me that, Dr. Dowd goes before me, so when she starts, that means I've got 20 minutes.
I think my brother's gonna be here. Can I ask him?
Yeah, I'll ask Dr. Simmons. She texts.
I'll go
Yeah,
first.
she's text. I think that's what the rest of the entrepreneur students are going for is extra credit. Yeah, she texts. Oh, she's...
Oh, is that the energy class?
Yeah.
She was reading a book on wind turbines.
Yeah. It's paired up with entrepreneurship. All right, A is, will it undergo SN1? A, yes. B, no. That actually wasn't the question I wanted to ask. But yes, it will undergo SN1 because it's a tertiary halide overall. So it would undergo SN1. My real question was going to be, does it undergo SN2? Right? Because that would be the other one. Does this one undergo SN2? It's a tertiary halide, can't undergo SN2. So I think a lot of what chapter 11 is going over is the bringing all four of these things together, which we've done a considerable amount. We've talked about strength of nucleophile. We've talked about leaving groupability. we've talked about the chart as to which one to choose, if it's a strong base. Now, one of the things I think they do is they classify something like like an ethoxide ion. They will use this in E2. If they do use it in E2, it's going to be a small base. I've kind of ignored this one, but it would basically follow the same rules. If it can do SN2, it will do it. It'll act as a nucleophile. If it cannot, it's going to act as a base and rip the hydrogen off. Bobby?
So would the answer, the major product for this still be A?
Yes.
Okay.
Yeah.
That's what I did.
Okay. So what we're going to do on Friday is I'll release the two answer keys for the homework set so that you can kind of check your work. Apparently, if it's not there, that causes great stress. So you can check your answers. If you have any questions on those, then bring them to class on Friday. What I said to the morning class was that if you have questions about that or questions about any of the SN1, SN2, E1, E2 stuff, to bring it, and I will spend the entire class answering questions if you have them. We will only sit and stare awkwardly at each other for about 2 minutes, because then it becomes really uncomfortable, and then we'll jump into chapter 12. So I'll leave that up to you. Monday, remember we have class Monday and Tuesday of next week, and we'll be doing chapter 12. So I will release chapter 12 also this afternoon. Jacob? Chapter 11 problems will be due the Monday after Easter. Thanksgiving. So that way, if you need some away from family time at Thanksgiving, you can go and do organic problems.
Do you still want the Friday?
No, well, if you're it'd be best to try them so that you can ask questions about them.
I mean, in chapter 10.
Chapter 10s are still due. Chapter 10s are still due Friday.
Okay.
I will request those items.